All right, so today's lesson is lesson 5.4 on special products. So the first thing that we're going to do, we're going to continue to multiply polynomials, but there are some special polynomials that I want you to recognize. So when you have a polynomial product set up in this way, parenthesis x plus a, close parenthesis, times parenthesis x minus a, you'll notice that these two terms are opposite. And something very unique happens. Let's just multiply the variables with the x's and the a's and see what we get here. So let's see, x times x is x squared. X times negative a is negative ax. A times x is positive ax, and positive a times negative a is negative a squared. And notice that these two terms cancel out. This is like saying 1ax and a negative 1ax. So these cancel each other out. So my answer is actually x squared minus a squared. So it says, can you see the shortcut? It's the only one of its kind. So maybe you see the shortcut, maybe you don't. But remember that this and this, like this multiplication, the 7x and the negative 7x, those cancel out. So really the shortcut is you just take these two terms and multiply them together or square them. And then you take these two terms and multiply them together. Yeah, so it's just that easy. So we're going to try using the first one. I'll use FOIL or distributive, either or, just to make sure you understand it. And then we're going to try and use the shortcut. So first two terms, 5x times 5x is 25x squared. The outside terms, 5x times 2y. Well, 5 times 2 is 10xy. The inside terms, negative 2y times 5x. Well, negative 2 times 5 is negative 10xy. And negative 2y, the last two terms, negative 2y and positive 2y. Negative 2 and positive 2 become negative 4. Y times y is y squared. Again, notice that I have a positive 10xy and a negative 10xy. Those cancel each other out. So I'm just left with 25x squared minus 4y squared. So for example number 2, I'm just going to use the shortcut. X times x is x squared. Negative 3 times positive 3 is negative 9. Because remember, multiplying these two together and these two together cancel out. Again, I'm going to use the shortcut. X times x is x squared. Negative 7y times a positive 7y is negative 49y squared. On my last example, I'll do another distributive or FOIL just so you can see it. X squared times x squared. First term of the first parenthesis times the first term of the second becomes x to the fourth. Now we're going to do the two outside terms. X squared times a positive 8 is a positive 8x squared. Now the two inside terms, negative 8 times x squared is negative 8x squared. Negative 8 times a positive 8 is a negative 64. Again, notice that these terms right here in the center are common, like terms. They cancel each other out. So I'm left with x to the fourth minus 64. All right. We've already done this, but here's another example. Squaring a binomial. So remember that when you square a binomial, you are really taking the binomial and multiplying it by itself. That's what it means to square something. So when I use the FOIL method, I end up with x squared plus ax plus ax plus a squared. So combining like terms, I have x squared plus 2ax plus a squared. So it does have a pattern. It sure does. And the pattern is a squared plus 2ab plus b squared. Now let me show you what that really means. What that means is if you have something like a plus b, the quantity squared, you take the first term and you square it. Then you take the product of 2 times the first term times the second term, and that becomes this. And then you square the last term. So that is your pattern. So let's try using the a squared plus 2ab plus b squared pattern. And I'm just going to write this over the top so you kind of have a reference. So let's see. If I follow the pattern, I'm just going to take the first term and I'm going to square it. That's 6x times 6x. Well, that becomes 36x squared. And then if I follow the pattern again, I'm going to take this first term and multiply it by 2. So I have 2 times 6x times the last term. Well, 2 times 6 is 12, times 4 is 48x. So plus 48x. And then I take the last term and I square it, plus 16. Now you can absolutely, if you don't like to use the pattern, if you don't want to like live from that pattern, you can absolutely FOIL 36x squared. 6 times 4 is plus 24x. 4 times 6 plus 24x. 4 times 4 plus 16. These two terms in the middle combine to give you 36x squared plus 24 and 24 is 48x plus 16. You do get the same answer. You do absolutely get the same answer. Now let's look at this example right here. So this is not the sum of squares. So this pattern works for the sum of squares. This works for the sum of squares, which is what we were doing right here. This example right here is the difference of squares. The difference of squares. And so the way that we do that, kind of same idea, a squared plus 2ab, a squared minus 2ab, because those are negative, a squared minus 2ab plus b squared. And I want to show you why that is. If I have a minus b, the quantity squared, well, that's a minus b times a minus b. A times a is a squared. A times negative b is negative ab. Negative b times a is negative ab. And a negative times a negative is a positive b squared. So when I combine these, I actually get a squared minus 2ab plus b squared. So this is the pattern for difference of squares. So let's kind of use the a minus the b idea and this pattern and see if we can use the cheat or the recognizing pattern first. So it says take the first term and square it. That's x squared. And then you subtract, right? We're going to do a subtraction. That's what this says. And we're going to take 2 times each term. 2 times x times negative 9, which is why we get a subtraction. 2 times x is 2x times 9 is 18x. And then negative 9 times negative 9 is a positive 81. All right. So we're going to practice that. So for the sum, remember we have a squared plus 2ab plus b squared. And then this one is a difference, a squared minus 2ab plus b squared. All right, let's see if we can't simplify these. So the first term squared, 4 times 4 is 16. Then I'm going to take the two a and b and multiply them together, and then multiply that by 2. 4 times x is 4x, times 2 is 8x. Then I'm going to take the last term and square it. X times x is x squared. Again, if you are struggling with recognizing the pattern, you can just use the FOIL or the distribution method. 4 times 4 is 16. 4 times x is plus 4x. X times 4 is 4x. X times x is x squared. That leaves you with 16 plus 8x plus x squared, which is the same as this trinomial. All right, example number 6 is a difference of squares. So we're going to use the difference. Take the first term and square it. 7x times 7x is 49x squared. Multiply the two terms together. 7x times y is 7xy times 2 is 14xy, and it's negative 14xy. And then take the last term and square it. A negative times a negative is a positive. Y times y is y squared. Example number 7, a difference. The first term, square it. Multiply the two terms. Negative 5x times 2 is negative 10x. Take the last term and square it. 5 times 5 is 25. This is a sum, so we're going to have plus plus. 2x times 2x is 4x squared. 2x times 3y is 6xy times 2 is 12xy. And then the last term squared. 3 times 3 is 9y squared. Again, if you are struggling with recognizing the pattern, I expect to see that you are expanding it like this, and you are using FOIL or distributive property to multiply these out. Telling me that you don't understand the process or you don't recognize the pattern is not acceptable. You're just not wanting to go the extra step and write it out. So recognizing the pattern is kind of like a cheat or a trick, right? But if you don't recognize that pattern or you don't understand the trick, then you need to write it out. All right. Suppose an orchard is planted with trees in a straight row. There are 5x minus 4 rows with 5x plus 4 trees in each row. How many trees are there in the orchard? Well, we are just going to take 5x minus 4 times 5x plus 4. Notice that these are called conjugates. They're opposites of each other. So this is the first rule that we learned up at the top. So I square the first term. 5x times 5x is 25x squared. And negative 4 times positive 4 is negative 16. Why do I do that? Well, because remember that when I multiply the other two terms, negative 4 times 5x, that becomes negative 20x. And positive 5 times positive 4 is a positive 20x, and those cancel each other out. Okay? All right. Area of a square. A square has a side length of 3x minus 2 centimeters. If I want to know the area, remember that the area of a square is just the side squared. So I'm going to take this binomial and I'm going to square it, which means taking 3x minus 2 times 3x minus 2. So I could use the distributive property or the FOIL, first term of the first parenthesis times the first term of the second, the outside, and then inside, and then the last of each. Or I could just use the method that we just learned and recognize the pattern. 3x, the quantity squared is 9x squared. Take the two terms and multiply them together. 3x times 2 is 6x times 2 more, because it's 2ab, is 12x, and it's going to be negative 12x. Take your last term and square it, plus 4. Okay? All right. The length and width of a rectangle are given by two consecutive odd integers represented by 2n plus 1 and 2n minus 1. Write a polynomial expression for the area of the rectangle. Well, again, area is just multiplication. So we're going to take the length and multiply it by the width. This is much like our apple orchard, our first problem. Notice that these are opposites. They're called conjugates. So 2n times 2n is 4n squared. 2n times negative 1 is negative 2n, and I'm writing that off to the side. Positive 1 times 2n is a positive 2n. I'm writing that off to the side. And then a positive 1 times a negative 1 is just a negative 1. This is my final answer because these cancel each other out. So it says complete the following statement. A plus b, the quantity squared, is not equal to a squared plus b squared because, well, why is that? Why are they not equal to each other? Well, they're not equal to each other because a plus b, the quantity squared, equals a squared plus 2ab plus b squared. Okay, so it says, but wait, isn't a plus b, the quantity squared, sometimes equal to a squared plus b squared? What do you think? So we'll come back to that one. Number 9, find the area between the two rectangles. So I'm going to find the area of the large rectangle. 3x plus 4 times 3x minus 4. So this is the area of the large. And from that, I'm going to subtract the area of the small. X minus 3 times x plus 3. Because you don't see the pink region, but this is the pink region. We're just trying to find this. Okay? So notice that both of these sets are opposites or conjugates. So 3x times 3x is 9x squared. 4 times negative 4 is negative 16. X times x is x squared. Negative 3 times positive 3 is negative 9. So I'm going to take the area of the large, and from that I'm subtracting the area of the small. Now remember what happens when you subtract. You have to distribute that negative through. So I really have 9x squared minus 16 minus x squared, because negative 1 times x squared is negative x squared, and negative 1 times negative 9 is plus 9. So I'm going to simplify this. 9x squared, whoops, sorry about that. 9x squared minus x squared is 8x squared, and a negative 16 and a positive 9 become a negative 7. So this is the area of that pink region. Okay. All right. So for your homework, you are completing page 18 and 19. And then we are really close to being ready for a quiz. So I'm going to make a quiz for us. So let's see, homework, page 18 and 19, and we need to have a quiz. So I'm going to get it ready for Tuesday. And your quiz is going to cover pretty much what we've done in the packet so far. So we are going to do multiplying a polynomial and adding and subtracting. So we'll do add and subtract polys, and then we'll do multiply a monomial by a polynomial, and then multiply a binomial by a binomial. Okay. No more than 10 questions. I'll try to limit it to actually 8 or 9, but 10 question max. And that's going to be a short quiz on Tuesday. Okay. Perfect. Don't forget to submit a screenshot of your homework from Wednesday in the Canvas module, you have a submission spot for that. Thank you so much, and I'll see you tomorrow.